The last time we sit down and had a chat, we led up to this point where we were getting ready to talk about biodiesel. Biodiesel, we said, was the counterpart to biofuel. Biofuel would be our gasoline version alternative, and biodiesel would be our bio alternative to diesel that's in the gas station, right? So hopefully that makes sense. But biodiesel can actually be made a completely different way than biofuel can be made from. All right, so we've already talked about the importance of the farmer and how corn or some other type of crop, it doesn't really matter if it's corn or not. Anything has sugar on the inside, and the sugar can be fermented, and that fermentation process can lead us to ethanol that we can use for a fuel additive or for a fuel source. So is biodiesel the same way? Well, in this video, we're going to talk about that. We're going to talk about the history of biodiesel, how it came around, when it came around, who was the first person to kind of wise up and say, hey, folks, listen, we have an alternative for this as well. So why don't we decide to use it? All right, so the man that you see on the screen here, his name is Rudolf Diesel. And he invented, guess what, the first diesel engine. And this diesel engine was before the year of 1900. But this diesel engine, when it was made, well, it needed a fuel source. What was that fuel source? It was vegetable oil. What? That's right. Before 1900, we could use ethanol in our engines to run our cars, and we could use vegetable oil in our diesel engines to run those. Well, there were some problems with vegetable oil. As you can imagine, it's pretty thick. If you've ever deep fried French fries at your house before and you reuse that oil a couple of times and you decide to clean out the pan gets a little gunky. It stays gummy and sticky and tacky. So these were some issues with vegetable oil that needed improvement, but guess what? Vegetable oil was used back in the day. Where does veggie oil come from? Hello? Where does the name say? Vegetable. Oh, okay. Well, to make matters kind of on top of that, even more involved in the farming industry, in the year 1900, they began to showcase these engines. And this was in Paris. And it just so happened that that engine that they showcased ran on peanut oil. Guess what you did in the summer, folks? If you took our 145 course, you extracted peanut oil from our peanuts. Hello? What could we do with that peanut oil? Yeah, we could take it to Chick-fil-A and say, fry our French fries or our chicken in it. But 1900, they ran an engine with it. Now, petrol sources, okay, this is petroleum based. They were available. Very few people were interested in it at the time, though, because those were more expensive. Does this story sound familiar? Folks, here's another encounter where today's bio world, renewable energy world, is old news. Before 1900, even when it comes to diesel engines, we can use resources from agriculture in order to do what we need to do with it. Vegetable oil and peanut oil can be used to run an engine in 1900. Folks, again, this whole concept of biodiesel, it's not new. This whole concept of using renewable sources to make this biological diesel that we can put into an engine because we're environmental friendly, this is not new. This is an old rehash idea that happened way before 1900 when all of the engines in the automobiles started to come around. Well, what's so funny is that Rudolf Diesel was the one who made the diesel engine, that didn't need diesel. It needed oil during that time from agriculture, from the farmer. Here's 1930s. Biodiesel engines begin to make their way inside of factories and everything, right? 1930s, what they discovered is that these fatty acids from what we called glycerin in vegetable oil created a thinner product. So a couple of researchers sat down at a lab bench basically and said, listen, vegetable oils are a great alternative. It's going to do its job. We're just going to have to make sure that it doesn't gunk up the insides of our engine parts, right? This was a problem. Again, very commonly seen if you use a lot of deep frying techniques at home. So vegetable oil, what is it made out of? Why is this thing working? Well, vegetable oil is made out of something that we call glycerin. I'll show you that in just a second. And there's fatty acids on the inside of this. Well, this is one of the reasons, folks, we talked about the lipid structure back in the day, right? At the beginning of the semester, we talked about fats. We talked about lipids. One of the reasons is because this is really playing a role in the diesel world. Who would have thought, right? But if we could take these fatty acids that I'm going to abbreviate as FA, and if we could liberate those fatty acids and cleave them off and do them individual fatty acids, then we're going to end up with a thinner product in the very end. And that thinner product can run through our engines a little bit better. It doesn't gunk up as much as normal vegetable oil would. It's just all around a better product. This was very similar as far as viscosity and density goes, like petroleum diesel. Very similar between the two. One just came from crude oil, and the other one came from something like corn or vegetable oil, which eventually led on down to a crop somewhere in some field. 1937, we get our first patent. This first patent was to make what they called biodiesel. They didn't call it biodiesel back in the day, though, right? They didn't have this term that they used. We use the term today in reflection of that, but they really didn't call it biodiesel. But it was this patent that they could take vegetable oil and they could convert it into something that was very similar to petroleum diesel that they could use and run in an engine. And 1 year later, after that patent was issued, we had our first car that actually operated on biodiesel. This was not the years of 2000. This was 1930s. 1930s, we have a vehicle that has biodiesel on the inside of it that is not a crude oil source, and it's moving. It's on the road. It's doing its job. Again, we don't call it biodiesel back in the day. That's a term that didn't exist. But we use that term now. 1930s. 1900, vegetable oil and peanut oil was used in engines just as they were. 1930s, a form of biodiesel was used that we basically call biodiesel today. That was getting used in cars. Once again, renewable energy or energy coming from non-crude oil is not a new concept. It's been tried, it's been tested, it's been done. 1970s, biodiesel comes along again. Why? Well, remember those embargoes that I told you about? Those embargoes not only affected gas prices, but gas is also strongly tied to diesel. So all of these embargoes had countries looking for alternative fuel sources. Ethanol was one of those. We've already discussed that. We've already talked about those in a few videos now. But folks, vegetable oil was brought back into the discussion. They knew kind of that it was used back in the day. So why not bring this to the table again and talk about it in a little bit more detail? Let's flesh it out a little bit. Well, once again, they said, listen, vegetable oil is going to be too thick for our purposes. You know, it's going to leave gunk. It's going to leave grime behind. So we need to create an alternative to this. We need change vegetable oil into something that we can use a little bit better. So they went into the lab and they did the same old rehash that they did back into the 30s with a few modifications. And what they ended up with was something that we called biodiesel at that time, and this happened in 1984, not 2004. Again, pre-1900, vegetable oil, peanut oil was used, not diesel. 1930s, we get our first car that ran on biodiesel, not diesel from crude. On top of that, 1980 comes around. 1980, guess what, folks? We put biodiesel into a vehicle. It's the same trend. It's the same trend. We have tried and tried and tried to get away from the oil industry dependence. And we have tried these resources time and time again. This is not new. This is not a new concept that we just came up with. Right? Environmentalists didn't spark this discussion. We've been having this discussion for over 100 years. And we've been trying it. We've been attempting it. Well, now what you can see at the gas pump are things like this, E10s and E85s. So E10s are 10% ethanol, E15s are 15% ethanol, which is 90% gas or 85% gas. There are E85s that are out there. And, that really depends on what type of engine that you have or what type of gasoline source that you need. But notice this is a flip. E85 is 85% ethanol. This was kind of discussed a little bit later or a little bit earlier in a previous video, and there was actually a mistake in the PowerPoint. That truly was a mistake at that time. But here we have advanced to the point where E85 is an alternative fuel source for us. 85% ethanol with 15% gasoline. And then we get something called B5. B5 means 5% biodiesel and 95% petroleum diesel. Very similar to the ethanol blended, but it's biodiesel blended. All right, well, that means that if B5 represents 5% biodiesel, then B100 means 100% biodiesel. And this is really what we refer to as biodiesel in a laboratory. So if we are trying to do some test on biodiesel that we have made, or a biodiesel source that has been given to us in a lab that we have to do some testing on, we regard that as B100. That B100 means 100% biodiesel. Nothing else added or blended to it. Well, we can take this biodiesel, we can blend it with regular diesel that we've become accustomed to all this time in different ratios and proportions. And B5, that's what that means, just like E10. That's what that means. E10, ethanol, 10%. B5, biodiesel, 5%. We have taken 5% of the mix, used biodiesel that maybe has been made from vegetable oil of all things, and we blend that in with a diesel and we put it into a vehicle and we run it. Why? For the same reasons. It makes it cheaper. You don't want to, again, pay an arm and a leg for gasoline or for diesel to put into your vehicle to get it to move. So we lower our dependence, we lower our demand on diesel just like we do gasoline. Now, how do we make this? I keep saying vegetable oil. Well, guess what? Vegetable oil is a fat. Again, this goes back to our lipids lecture. You now know the basics of a lipid. And we're going to start with a triglyceride. All right, so keep in mind, glycerol is a 3-carbon chain, and off of each carbon, we traditionally have an OH group. That is what we would call glycerol. Okay, well, triglyceride. Well, here is my glyceride functional group, if you want to label it as that, in that molecule. 3 carbons linked up side by side. Tri means 3. Here's group 1, There's group 2. Here's group 3. Off of each one of these carbons, I see this ester piece, right? This is a ester. An ester is a carbon double bond O on another oxygen. That is what that means. I see it here. C double bond O, O. C double bond O, O. C double bond O, O. And off of each one of these, just a random group, it doesn't really matter what it is. Vegetable oil has random groups that are there. Those are groups, they're typically hydrocarbons. So they are typically carbons and hydrogens that are all the way down. We talked about this in lipids, right? In that whole lecture series, that's what we talked about during that time. And these can be straight, or these can also have double bonds on them, saturated or unsaturated. And we talked that this is the difference between an oil and a fat. All of that's coming back. So I get this triglyceride. This triglyceride is 3 carbons holding hands. On off of each one, I have an ester group. If I can cleave those ester groups off, then I can free up these what we would call fatty acids. Here is my fatty acids. That's what these are going to be regarded as. Why? Because this piece, O carbon double bond O, if there was an H right here at the very end, this gave us our carboxylic acid. We said that's what fatty acids were back in the day. They were carboxylic acids with carbon chains. So if I can cleave these, I can free up the fatty acids. If I can free up the fatty acids, guess what, folks? I've created what we call biodiesel. That's all it is. That's all the reaction is doing. So in the lab, this is what you're going to be doing. You're going to be taking vegetable oil. Any oil would actually work, but vegetable oil can work. This vegetable oil is a lipid. This is a triglyceride. Off of each one of these carbons, vegetable oil has these ester groups that are hanging off of it. We're going to cleave these ester groups off of it. We're going to cleave the ester groups off. When we cleave the ester groups off, we have now free fatty acids. And those free fatty acids are what we call biodiesel. What we have left behind are all of these carbons, this 3-carbon chain. Well, we can't really forget about these, all right? If we forget about them, well, we're not really doing it some justice. So over here, as another product, guess what we form, folks? We form glycerol. You can kind of imagine here this OH group from the methanol added in on top of each one of these carbons in order to give us those OH groups. It's not actually what happens. The mechanism here is a little bit more complicated. How this reaction goes forward, what groups react with what bonds form with what, it's a little bit more complicated than that, but I'm going to lie to you here, and I'm going to say this is the easiest way to see it. Cleave off the free fatty acids. I have biodiesel. Those carbons now need a bond. Put on some OH groups that are there, and we get glycerol as another product. What does this require? This requires some type of alcohol. All right, methanol is typically used because it's pretty cheap and it's very easily reactive. And then we also are going to put some sodium hydroxide into the mix. We're going to have some alkaline alcohol that drives this reaction forward. But notice the arrows here. That means equilibrium. I can take methanol and the vegetable oil, I can drive it forward to make biodiesel and glycerol, or I can take glycerol and the biodiesel and I can drive it backward to give me this triglyceride and the methanol. This is the whole thing about chemical equilibrium, the back and forth of various reactions that can go on. What we hope is that we drive to the product side. We want the biodiesel in the laboratory. We don't want to revert back on itself and give me the starting products again, do we? Well, we got to be careful because this reaction, it can happen. Here's another image of the same type of thing, just broken out in different colors, so maybe you can see it a little bit better. As you can tell, they focus here with the pink box on the tri-carbon group, and they're letting you know that right here to the left, this is a piece that's there that we start with, and to the right-hand side, that piece is still there, but now we have these OH groups that are on it, and this is called glycerin. Glycerin and glycerol are the same thing. All right. Here on the blue boxes, these are the individual esters. These are ester groups that need to be cleaved, and we can cleave them off. Well, we can cleave them off, and we can put hydrogens out here on the side to make what we would call the formal fatty acid, or carboxylic acid, the formal carboxylic acid. Or, in the case of methanol, what happens here is that this CH3 group is going to go on to those esters. And this will be a mixture of fatty esters. If these were OHs, again, that would be a mixture of carboxylic acids. And we're after the esters here. Fatty esters. All right, here's another depiction of the same type of reaction, just drawn a different way. But what I like about this one is that they actually name the product. They just don't call it biodiesel. If you look, they're calling this fatty acid methyl ester. All right, I want to dissect that name here a little bit. Ester group is right here. C double bond O and O. That is my ester group. Fatty acid means that these basically came from oils. Those oils were generated through fatty acids at one point in time, and those fatty acids got linked up, but now they're cleaved off. That's where that term fatty acid comes from. Again, if this CH3 group was not there, and we had an H that was here, that would be called a carboxylic acid, and in the field of lipids, that would be called a fatty acid, not a carboxylic acid. But we don't quite have that here, do we? So we call it fatty acid. Methyl. Methyl, why? Because there's a methyl group that's attached here to the end. So here's my methyl. Here is a fatty acid, or what would have been a fatty acid, on an ester group. And we call it fatty acid methyl ester. We have an abbreviation for this, and it's called FAME. So, if I'm making biodiesel, it looks like I need some methanol. It looks like I need some sodium hydroxide to get this reaction to go forward. I create these two different products. Glycerol is one of those products, and FAME is another product. And this is what we would call our biodiesel. FAME has a test. This test can be done in a laboratory on an analytical piece of equipment. We'll talk about that when we talk more details about the lab that you're going to be doing with it. But this is what FAME is going to stand for. Fatty acid methyl ester. It is in specific regards to the field of biodiesel, but this is kind of a more scientific-y term that's given to this product name. All right? So when you start reviewing these laboratory tests and you start seeing the word FAME show up everywhere, that's basically what that is. Here's another depiction of this type of reaction. What's different about this one is that up here at the top, they are drawing a free fatty acid. Notice here it is a true fatty acid. I see the carboxylic acid group on the end. Again, we talked about this in lipids. And then here they're also giving me a triglyceride form. So this is a 3-carbon chain. Look, there's 1 carbon, here's 2 carbons, there's 3 carbons. Off of these carbons, I have an O, C double bond O, O, C double bond O, O, C double bond O. And what they're letting me know is that both of these can work. All right, both of these can work, and they can give me a couple of different things if I'm not careful. If you look here, they just talk about releasing CO2, releasing water. They just said catalyst, and that's about it. But they have a different type of product over here. Look at this. This is not an ester product, right? That's not like the product that was drawn here. This truly is the fatty acid methyl ester product. I see the ester groups in each one of these. But in this reaction, it's a little bit different because there's no ester groups that are here. These are all straight chain hydrocarbons. There's no oxygens. It's all just carbon and hydrogen. Well, these are also called paraffins. A hydrocarbon is called a paraffin. And these straight chain paraffins can then be reacted. Notice here it says catalyst, and they write H2. And what we do is that we branch these paraffin molecules. What was a straight chain is now a straight chain that's a little bit shorter, and those extra carbons are just sticking off of the main chain. Look, here's one, there's one, here's a branch, there's a branch, there's a branch, there's a branch, there's a branch. When we branch these molecules, we start changing the boiling points, we start changing the actual structure itself. This is just another reaction that shows you what we could do with vegetable oil, or any type of oil for that matter. I can take these oils, I can react them in a different way, and I can get full-blown hydrocarbons. These are hydrocarbons that would be found in crude oil. My pentanes, my hexanes, my heptanes, octanes, nonanes, decanes. I could get those products from things like vegetable oil. Those products are found in crude oil. They're components of gasoline. And then if I'm not happy with that, I can then take these straight chain molecules like pentane, 5 carbons in a row, and I can react those in a different way and get something that I would call maybe isobutane from them, and we would get a branched chain. So I could get all of these alternatives in the organic chemical world just through the reaction of lipids, fats, and triglycerols. Folks, not only could vegetable oil dabble in the biodiesel sector to give me biodiesel in form of these ester groups, but oils like vegetable oil can also be reacted with to give us products that would also be found in your traditional gasoline sample. And if not gasoline, these are very common chemicals that we use in a laboratory environment. All coming from vegetable oil, which basically comes from vegetable, which is a crop in a field on a farm. Well, the nice thing here is that I just keep saying veggie oil, right? Veggie oil. But what type of veggie oil? Are there specifics here? Well, that we'll talk about in the next video. We're going to look at this vegetable oil in a little bit more detail. We're going to talk about what's suitable for this reaction to go forward or for this reaction to go forward. Do we need something super clean, like most of the time we do? Well, we'll figure that out when you come back.